differentiate sine of 3x. Okay. Now, so far, when you've been doing chain rule, you've gotten familiar enough with it that you skip out doing the full steps with like, let u equal this, blah, blah, blah. But just because we're starting a new family of functions, I'm going to do it. Okay. So let's call this whole thing, let's let y equal sine 3x. Okay. So let u equal 3x. Okay, and do you remember how did chain rule work? Well, we wanted to say this was sine of u. Okay, so I differentiate the inside, I differentiate the outside. Here's the inside, right? So du on dx is just 3. And here's the outside, dy on du. Now this is sine, right? So it turns into cosine. Okay, so it's going to be cos of u. Okay, not cos of x. This whole thing, we've gotten rid of the x's. Okay, so therefore, back to the original definition of chain rule, right? dy on dx is, here's my chain, dy on du, du on dx. Okay, so you can see it's 3 cos u, which is 3 cos 3x. Okay, so now if you like, you can see how this works. You can, once you feel comfortable with it, go straight from here all the way down to here. Because you think to yourself, what's the inside function? 3x. Differentiate it, put it out the front, and then differentiate the outside. Sine turns into cosine. Okay? Alright, let's ramp it up a little bit. How about the derivative of tan, let's say, oh, I don't know, x minus 1 on x. Okay, now what is this? This is, wait, right? No, I want it upside down, sorry. X on x minus 1, that's better. What is this? This is, number 1, it's chain rule, because you've got tan of something. And then number 2, it's quotient rule. Okay? So when you've got questions like this, it's worth the effort and the time, rather than doing this all in your head. You say, maybe off on the side, or maybe underneath, you say, the derivative of, and then you just think about the inside function. And you forget about the tan for a minute. Okay? So what's the derivative of, x on x minus 1? Let's do quotient rule together, shall we? U and v. Okay? V on v squared, right? So v, x minus 1. U dash is just 1, so I'll leave it off. Minus u, which is just x, again, times v dash, which is also 1. All over v squared. Okay. This turns out to be very conveniently just minus 1. Okay. So now that I know, why was I doing this? This is the derivative of the inside. Okay? So now I can say the derivative of this is this. There's the derivative of the inside. Minus 1 over that. And then you differentiate the outside. Tan turns into sec squared. Now I admit, this is just the beginning, so you're like, man, I'm in trouble remembering all this. The best way to remember it is to use it. Okay, use it or lose it. It's just like a musical instrument or a sports skill. As you get familiar with it, it'll become, I promise, okay? So, tan turns into sec squared. Sec squared. Now, by the way, this is easy to forget in chain rule, right? Especially if you don't do the full substitution, okay? It's not sec squared x, because the original function had all of this mess inside there. So the mess comes with it, okay? So this is x on x minus 1. There's the derivative, okay? How about, you can handle this. How about x cubed, tan x? This is product rule, isn't it? Okay. So actually, let's do cos because we just did tan. Okay. So this is product rule. So there's a u and a v. Okay. It's a product which is just a vuv. So cos x, u dash, which is 3x, bring the power down, squared. Careful with your brackets, by the way. You don't want to get that x mixed up with this 3x squared. Plus u and v dash, which is minus sine. Watch out. Okay. So cos is a pain. It goes backwards. Okay. So therefore, this is 3x squared. We tend to write the polynomials, the powers out the front, because then you don't get it confused with the trig function. minus, and if you wanted, you could factorize, but that's enough. Okay?